out the zeros, and basically you end up with f of x is equal to a n parentheses x minus c1. So c1 and c2 up to cn are numbers, and then you have your x values. And a, it's either going to be given to you. So if they say a is equal to 2, at the end you're just going to multiply or distribute the 2. Another way they'll give it to you, let's say they say f of x is, well, not f of x, but they'll say something like f of 3 is equal to 4. So here your x value will be 3 and your y will be 4. But remember, y is also known as f of x. So you would substitute in every x a 3, and for f of x, you would substitute a 4. And then you would solve for a. Once you find a, you would substitute it back um, without the x and the y, and then you have your function. Complex zeros occur in pairs. So the main idea here is that if they give you a zero to be a plus bi, then you need to have its pair. So you need to have the a minus bi. Same thing over here. If they give you one of the zeros to be a minus bi, you need the plus. So always complex numbers, they come in pairs. Let's take a look at number 1. So number 1, we're going to find the fourth degree polynomial of the function with the real coefficients that has -1, -1, and 3i as zeros, and let a equals to 1. So we're going to use this theorem up here. So we're going to be using this part right here. So we're going to write f of x. And the next one, remember, it's our letter a. So a sub n. And they tell us that a is 1. So here we could just go ahead and write 1. We look at our first zero. So it's going to be the opposite sign. So it's -1. So it's going to be +1. And then our next zero is -1. So +1. And then we have a complex. So here we're going to say x minus 3i, and then we need its pair. So this one needs the plus 3i. These two right here, these two terms, or these two factors, can be written. You could write it as x plus 1 squared. And there's a nice little rule where it states that if you have a plus b squared, this is just a squared, and then you're going to say 2 times a times b, and followed by b squared. So here, those two, remember that it's going to be x squared, and then you're going to have 2. So 2 times a, which is x, so 2 times x, times 1, which is b. So here you get 2x. And then finally, b, in this case, is 1, so you just say 1 squared. So with that, we have x squared plus 2x plus 1. And remember our complex conjugate? Hopefully you still remember, it's going to be a squared plus b squared, since we have the difference. Okay, so here our a will be x, so it's going to be x squared, and then our b will be the 3, so we have plus 9. So remember, negative 3i times 3i is equal to negative 9i squared, and I squared is a negative, so that's why that one becomes a positive. So here we could go ahead and distribute. So a good way to do this, just x squared times our first factor, which is a 2x plus 1, and then we get the 9, so plus 9 times x squared plus 2x plus 1. Distribute, so we have x squared plus 2x cubed plus x squared plus 9x squared plus 18x plus 9. We combine like terms, so here we're going to get f of x is equal to, and we only have x to the fourth once, so that one's done. Next up is x cubed, so there's only 1, so it's going to be plus 2x cubed. So I'm going to circle that to make sure that we're that way I'm keeping track of what I'm writing. The next one is x squared and plus 9 squared, so we're going to say plus 10x squared, so that's gone. And then we have the plus 18, and then we have the plus 9. So those were the last ones. So here is our fourth degree polynomial. go ahead and try the checkpoint